People often call Elon Musk the real-life Tony Stark because he directs a massive array of advanced technologies. In a late-night television interview, Stephen Colbert framed the situation directly. He pointed out that a billionaire deploying vast resources to alter the world usually falls into one of two categories, a superhero or a supervillain. Musk deflected the title entirely. He insisted he is simply trying to do, quote, useful things. Those useful things range from household solar panels to automated snake chargers that jack into electric cars, looking like mechanical tentacles from the Matrix. But there is a reason these disparate projects, from solar panels to robotic chargers, are being built simultaneously. It stems from a specific calculation, that our technological window to reach another planet is open right now, but we have no way of knowing how long it will stay that way. From this perspective, Tesla, SpaceX, and SolarCity aren't separate businesses. They represent a list of dependencies, the foundational hardware required to turn a destination like Mars from a distant light in the sky into a backup for humanity. Getting a payload off the ground requires massive physical infrastructure. This chart highlights the core economic barrier to spaceflight. Imagine flying a commercial airplane from New York to London and then throwing the entire 747 into the ocean after one trip. That is how multi-million-dollar rockets have historically operated, discarded after a single use. But if you can land the main booster stage back on Earth and reuse it, the total expense line collapses. You stop paying for a new vehicle and only pay to refuel it. Testing that theory in the real world leaves zero margin for error. Breaking out of Earth's gravity requires immense thrust. Thousands of pounds of fuel burn every second just to push a payload out of the atmosphere. After dropping off its cargo in low Earth orbit, the first stage re-entered the atmosphere, fired its engines, and executed a vertical landing. That single landing proved reusable rockets work. The math now supports colonizing Mars as a viable logistical blueprint. Once you solve the transport problem, you still have to deal with the destination. Mars is a freezing, uninhabitable wasteland. At first, anyone who goes there will have to survive inside enclosed, transparent domes. Those domes will need an enormous, reliable energy grid to keep the inhabitants alive. Developing highly efficient solar panels on Earth is critical, because early Martian colonies will have to generate all of their power off-grid. This diagram illustrates the long-term plan. Musk considers Mars a planetary fixer-upper that eventually needs to be terraformed or artificially warmed up to create a breathable atmosphere. If you want to warm it up quickly, you have to introduce massive, instantaneous heat directly over the Martian poles to melt the trapped ice and release carbon dioxide. The most efficient mechanism we have to generate that kind of immediate heat is detonating nuclear weapons. To create an environment where humans can survive in the open air, the plan calls for deploying our most destructive weapons as heavy-duty landscaping tools. When you tally the required inventory, automated robotic snake tentacles, and a willingness to drop thermonuclear bombs on another planet, Colbert's science fiction villain comparison holds up. Yet these terrifying concepts are governed strictly by physics. To solve the hardest logistical problems humanity has ever confronted, engineers have to build extreme tools. We happen to exist in a rare stretch of history where the technology to leave Earth is finally catching up to the ambition. We have no guarantee how long this window will stay open, before resources, politics, or an extinction event shuts it. There is a shift in perspective when you realize these milestones are being reached in real time. It means waking up to see the physical expansion of where life can actually survive. Every safely landed rocket and newly manufactured electric batteries serves a distinct function. They are the physical, working gears of a master plan to ensure our species survives.